In question 9, it says A, B, and C are points on horizontal ground. The bearing of B from A is 72 degrees. The bearing of C from A is 205 degrees. AB is 170 meters and AC is 95 meters. Calculate BC. So bearing of B from A is 72. This is 72. And bearing of C from A is 205. This entire is 205. So we have to calculate BC. This is X. So first we'll find this orange angle, which is going to be angle CAB, which is going to be 205 minus 72, which is going to equal 133 degrees. As we can see that we have two lengths and the angle between them, and we have to calculate the third length. So that means we can apply the cosine rule, because this is the condition for the cosine rule, two lengths and the angle between it. If that's present, then you can apply cosine rule. So for cosine rule, the formula we're going to use is BC square equals to AC square plus AB square minus 2 times AC times AB cos of angle A. Now, the reason why this is our formula, because like the missing length is BC. So since the missing length is BC, that means the angle we're going to use is the one that's opposite to BC, which is angle A. Hence, BC square equals to AC square plus AB square minus 2 times AC times AB times cos of A. So X square, since I assume that BC is X, equals to 95 square plus 170 square minus 2 times 95 times 170 times cos of 133. So we know 95 square plus 170 square is 37,925. And then we do 2 times 95 times 170 times cos of 133. That's negative 22,028.54. Now, always remember this when you're using the cosine rule. Solve this collectively first and then subtract the result from the 95 square, the sum of 95 square and 170 square. If you just directly subtract 2 times 95 times 170 from the sum, then your answer is going to be incorrect. So first multiply the entire thing, multiply the value of cos, and then subtract the result. So 37,925 plus 22,028.54 is 59,953.54. We take the square root on both sides. And that's going to be 244.9 meters. Then it says find the bearing of A from C. In order to find the bearing of A from C, let's first draw the compasses at A and at C. So we know that this entire angle is 205. So if we subtract 180 from it, that is going to give us this small angle over here. So 205 minus 180, that gives us 25. Now, if you remember, if we have two parallel lines, alternate angles are going to be equal. This is one parallel line and this is a second parallel line. And since these two angles are alternate, that means bearing of A from C is going to equal to 25 degrees. So the reason why I'm adding a 0 with 25 is because bearing is always written in a 3-digit. It's not written as 2 digits. Part C says the point D lies on the horizontal ground due south of A and due east of C. Show that AD is 86.1 meters correct to 1 decimal place. So we know this angle is 25, which we calculated in the previous part. So we have to show that AD is 86.1 correct to 1 decimal place. So what I'm going to do is, this is the length that we're trying to find. We have this angle. This is a right angle, so this is our hypotenuse. This is our adjacent, because this is the line on which the angle lies, and this is our opposite. We have the hypotenuse, we have the angle, we have to find the adjacent. So we'll use cos theta, which is adjacent over hypotenuse. Cos of 25 equals to x over 95. 95 times cos of 25. And that is 86.09 meters. Correct to 1 decimal place, it's going to be 86.1. A point X is at the top of a vertical mass at A. The angle of elevation of X from B is 7 degrees. Calculate the angle of elevation of X from D. So X is at the top of a vertical mass at A. So let's say X is over here. And they're saying that the angle of elevation of X from B is 7. So that means this angle is 7. This angle is 7 degrees. And then they're saying that calculate the angle of elevation of X from D. So first I'm going to find AX. This is a right angle triangle. So that's going to be tan of 7 equals to AX over 170. The reason why it's AX, because this is the length on which the angle lies. So this is our adjacent. This is our opposite. So tan 7 equals to opposite over adjacent, which is AX over 170. So 170 times tan 7 is AX. And that's going to give us 20.87 meters. Then we have to figure out the angle of elevation of X from D. So let's just redraw this diagram over here. We already figured out what AX is. X is over here. at the top of a vertical mass at A. This is A, this is B. This was 170 meters. Angle of elevation was 7 degrees over here. And AX we found as 20.9 meters, like if we rounded the 20.89. So this is a 90-degree over here. They want to calculate the angle of elevation of X from D. If we go to the question said that point D lies on the horizontal ground due south of A. So south of A can be over here as well. And if we connect this point over here from X to D, this is another 90-degree angle over here. We have, let me just change the space. This is 20.9. And they want us to calculate this angle. We already found the distance of AD, which was 86.1. So we have the opposite, we have the adjacent, we have to calculate this angle. So what we can do is we can use tan again. Tan of angle D equals to 20.9 divided by 86.1. So D would be tan inverse of 20.9 divided by 86.1. And that is going to equal 13.6. That is your answer.